Okay, students, in this lecture we are going to study about the stereoisomerism. Already you are aware that we have done isomerism, all type of isomerism in the first lecture itself. In the less than 40 minutes, we have completed all isomerism. Structural isomerism we have completed. If you have not gone through that, kindly go through that. I will give the link in the description box. Okay, and don't forget to give a like to this video. I am doing a lot of efforts for giving you the best in the shortest possible time. Until unless um, you go through the till last of this lecture, because in the last of this lecture I am going to give you how to find out the number of geometrical isomers. That formula I am going to give you. In the recent trend, there is a number of questions are there in the integer type. Okay, so to cover those questions, these type of questions are very required. I hope you all will start this video with a like and share it to your friends so that they can also be benefited. Let's start with the stereoisomerism geometrical, and we will try to finish off in the shortest possible time without leaving anything, right from the basic to advanced. For that purpose only I am using the slides so that you can get the benefit of time management. Okay, and you can get the clarity. Okay, so let's start with the geometrical isomerism. Okay, in our previous lecture we have done about the isomerism left part of this chain. Okay, now we are going to study about the right part of this chain. Okay, so this flow chart already given in our previous lecture, that is isomerism. Constitutional isomerism or structural isomerism we have completed in our previous session. Okay, so now we are going to start with the stereoisomerism, and in this stereoisomerism we are going to cover this part: geometrical isomerism or cis-trans isomerism. So most of the people are having wrong assumption, means geometrical means cis-trans only. So I will not only cover cis-trans isomerism, somewhat related. There are plenty of isomers. So with the examples we will try to cover up. So with these slides, it will save up your time and give you the good clarity. Okay. So what is our aim? Is it understood? Stereoisomerism. In that there are two types of isomers. Conformational isomers. Conformational isomers are found in the hydrocarbon with the sigma bond. Okay. So when there is only one bond between the carbon atoms, there will be rotation possible across that sigma bond. Suppose this is the carbon, this is the carbon. Now it is attached with three groups, it is attached with the three group. So the isomers obtained by rotation about this axis. So we will be keep on rotating this. You will keep one of the carbon atom fixed and rotate this. So there will be distance between there will be change in the distance between the groups attached on the each carbon atom. That will keep on changing. So such isomers called as a conformational isomerism. Okay. Now in the other than the rotation, sometimes rotation is not possible, or other than the rotation, whatever the isomers we get, they are called as a configurational isomerism. Stereoisomerism is directly 3D concept. Okay. So you cannot draw it on the plane of paper, but there are some type of representation given to enable us to explain the 3D concept on a 2D paper. Okay. So what are those representations that we'll come to know before going through the optical isomerism, like normal line, broken line, okay, and solid wedge. These are the three representation used because we cannot draw the 3D diagram on a plane of paper. Okay. So there we will use these three: normal line and broken line, and it is called solid wedge. 3D, why? Because on the plane, below the plane, above the plane. Three dimensional. Okay. One dimension is on the plane of paper, and this is below the plane of paper. This is above the plane of paper. Okay, all the three will be covered by using the proper representation. Okay, so geometrical isomerism or cis-trans isomerism a part of it. Understood that we are going to study now. So now let's go to the next slide. Okay, stereoisomerism, what is that? It is also called as a space isomerism, 3D isomerism or space isomerism. Compound having same molecular formula. So once we say it is isomer, the main condition it should follow is it should have the same molecular formula. Okay. Now additional condition, same connectivity. So this carbon is connected to this. If it is not connected to in the other isomer, suppose A is attached here. In the other isomer, A is not attached here. Okay. So if it is attached here, then it will go into the structural isomer. Now in this, this will be on the carbon, same carbon only. And structural formula also same. Connectivity also same. Molecular formula will be same. But different due to spatial arrangement. Okay. What is the main difference? Like if functional group is different, we call it as a functional isomer. If location of multiple bond is different, then positional isomerism. Like that we call. So everything, all the three conditions should be satisfied. Molecular formula should be same. On the same carbon it should be connected. Structural formula also must be same. Okay, so that it should not counted as a structural isomerism. But what will be the difference? Spatial arrangement of atom or group of atoms is said to be stereoisomers. Okay, so they are further divided into configurational isomer and conformational isomer. Conformational isomer already I told you, this is more regarding the hydrocarbon, in that we are going to study in depth. So let's start with the configurational isomerism. Configurational isomerism. Okay. Now next let us see. So configurational isomerism. In the configurational isomerism, stereoisomer which are not interconvertible at room temperature. Okay. So once they are formed, it is not that we can change from one isomer to another isomer. They are called as a configurational isomer. Okay. The isomer which are not interconvertible from one form to another form. Once we say this is isomer A, so that will be remaining as A at room temperature. We cannot convert into another isomer B. So they are called as a configurational isomerism. They are further divided into geometrical isomerism and optical isomerism. Okay, geometrical isomerism and optical isomerism. Now let's go to the next chart. Here the main topic starts, geometrical isomerism. Okay, this today's topic is, in this lecture we are going to study completely about this. Okay, so geometrical isomerism. This is type of a configurational isomerism which arises due to restricted rotation. This is main word. Okay, restricted rotation of atoms are groups around the double bonded system. Okay, either two places it will be, either there should be a double bond, either there should be a double bond, or second it should be a cyclic, cyclopropane, cyclobutane. Okay, cyclo system must be there. So because of these two, what happens? Restricted rotation, that means rotation is not possible. So if rotation is already possible, then it will go for the conformational isomerism. Then it will go for the conformational isomerism. Okay. So what is restricted rotation? I am going to show you here. So like suppose this is the one bond, this is another bond. Okay. So between the two, this is one carbon, this is another carbon. Okay. So these two carbons are double bonded. So because of that, what happens? When it is rotated, one of the bond will break like this. Okay. Suppose if it is only one bond is there. Okay. This is one carbon, this is another carbon. If both are connected together through a single bond, then there is no problem of the rotation. Okay. So the rotation is restricted due to the presence of second bond. So once it is rotated, one of the bond will break, and that either that will restrict or that will break. That is called as a restricted rotation. Okay. So restricted rotation, I think it is clear now. Either restricted rotation must can be either double bond or cyclomeans. Cyclomeans, each carbon will be attached to two other carbon atoms. Okay. Now, condition, restricted rotation and different functional group. This is the one primary condition, okay, for restricted rotation. Second is different functional group around the system, which shows the geometrical isomerism. What is this different functional group or different atoms? That I will explain each and every one. Okay. So as I told you, people are thinking that geometrical isomerism is only cis trans. No, it is one of the part of the. I consider it as a major part of the geometrical isomerism, but it is not complete part of the geometrical isomerism. Geometrical isomerism consists cis-trans isomerism, EZ isomerism, syn and anti-isomerism. What are these isomers? How they happens? And what is this different functional group that we are going to see it now? Okay. Okay. Now this is what where restricted rotation also must be there. Okay. So, cis-trans isomerism, when like atoms are groups attached to the same side of the double bond, okay, like atoms, that means same type of atoms, attached to the same side of the double bond line or double bond plane are called as a cis. And like atoms are group are on the opposite side of the doubly bonded carbon atom are called trans. Okay. So here like atom, suppose this is A, this is A. So many people are doing wrong because of this not taking safety precaution. You should draw a line across the double bond like this. Okay. So this is a double bond plane. So with respect to the double bond plane, what happens? They are these two A are on the top side, these two B are on the bottom side. Same way here, if you see, this is the double bonded plane. Okay. So double bonded plane, one A is on the top, one A is at the bottom. One B is on the top, one B is at the bottom. Okay. So these are called as a trans. Okay. So geometrical isomerism, I think it is clear now. If similar groups lie on the same side of the double bond plane or double bond, then it is called as a cis. So how to remember this cis? And here in the cis only there is a same, cis and same. Okay. So cis means on the same side. Trans means you have to transport, you have transfer from here to here. Okay. So like that you can remember to avoid the confusion in the last moment of the exam. Okay. So for example, this is only general formula I have given. For example, here like atoms A are chlorine. So both chlorine lie on the same side with respect to two double bond. Okay. And with respect to double bond, chlorine are on the opposite side. And it is not necessary that other two also must be same. Okay. So that also I will take example. So these hydrogens may or may not be same. Okay. So let us take bromine. Let us take another example, bromine. So it is not necessary that both must be hydrogen only. One can be hydrogen, one can be methyl. Still it is cis isomer, like atoms on the same side. At least two like atom must be there. Okay. And second example of the trans will be here bromine will be this side and another bromine will be this side. And hydrogen will be here and methyl will be here. So if like atoms are on the opposite side, then it is called as a trans. So this is an example of trans, this is an example of cis. This is an example of cis, this is an example of trans. Okay. Okay, now let's see the other part. Okay, next EZ isomerism. Cis trans isomerism we have done. Then what is about Z isomerism? Okay, sometimes what happens, we do not get similar atom. Like in the previous example, I have taken two chlorine atoms same. Okay, and in another example, I have taken two bromine atoms same, but two hydrogen atoms are not same. In chlorine atoms are same, and hydrogen also same. Here hydrogen is not equal to methyl. But in some cases, even these two chlorine also will not be same. Okay. So the above system is used. EZ system is used for the derivatives of alkene, which all four substituents are different. Okay. See here one is A, one is alpha, one is B, and another is beta. So you cannot say which is cis, which is trans. Okay. Then what we will do, we will give a numbering. Okay, we will give a numbering to these two, we will give a numbering to these two. Then if the numbering, during the numbering, let us take this is one high preference, that preference rules will be given by the can engold prelog rules. Okay, normally people think that three rules are there, but actually four rules are there. Okay, so we will study four rules. Can in gold prelog. This is shortly it is called as a CIP rules. It is shortly called as what? CIP rules. So by giving by following the rules, we will give the preference order. Suppose this is first preference, this is second preference, and this is first preference, this is second preference. So first preference on the same side of the double bond, then it is called as a cis. Okay. Suppose if it is here and if it is here, then this is 2, this is 1. Okay, then it will be called as a trans. Okay, and here cis and trans is different. Okay, cis is called as a Z here. Okay, trans is called as a E here. Okay. So how you will remember in the exam, again there will be confusion. So that is what the problem people are facing. Okay. As I told you, cis S stands for same. Same way here Z stands for cis is just to take the name of Jesus. Okay. Jesus. Jesus. Okay. So Z will be equal to cis and opposite will be trans. Okay, opposite will be trans, E trans. Okay, so here see both first preference will be on the opposite side, that means trans. Okay, and if they are on the, so of the following set of the rules can involve prelog rules, substituents on the double bond are assigned priority. This is first priority, this is second priority, this is first priority, this is second priority. That assigned rules are there. That rules also we are going to study now. So after assigning, the double bond is assigned configuration E. If E means actually German word, it is antagon. That German word meaning is that it is opposite. Okay. If the two groups of higher priority on the opposite side of the double bond, opposite side of the double bond, antagon. Antagon means opposite. Okay. So now let us see the what is trans. Okay. Or what, sorry, what is E. Okay, so already we have seen about the E. Now we are going to do it about the Z. Okay. On the other hand, double bond is assigned with the configuration of Z. Z means Jessamine. Okay, Jessamine again German word together. Okay. So high priority, first priority is on the same side and second priority on the same side. Then it is called as a Z. Okay. Z for cis and E for trans. Okay. Okay. This is about this Z and E, second type of isomerism. Now we are going to see the next slide. What is CIP rules? Can, in gold and prelog. These are the three rules. Okay. CIP, can, in gold, prelog. So these are used to assign priority. Okay. So rule 1, when atom or group of atoms which are directly, First of all, EZ isomerism is used when all four groups attached on the double bond carbon are different. Okay. So like here, fluorine, iodine, chlorine and bromine, all of them are different. Okay. When atom or group of atoms which are directly attached to stereogenic center, stereoisomers. Okay. So this is giving the stereogenic center. What is not stereogenic center, that I will tell you. Let us take here hydrogen and here also hydrogen. Okay. And here it is methyl, here it is methyl. So in this condition, there is no possibility of geometrical isomerism. There is no possibility of the if when both groups attached on the same carbon, when the both group attached on the same carbon are different, when both group attached on the same carbon are different, then only it is going to give you geometrical isomerism. Okay, then it is called as a stereogenic center. So here both group attached on the carbon atom are same. So there is no possibility of cis trans isomerism. There is no possibility of geometrical isomerism at all. Okay. So this is not a stereogenic center. This is not a stereogenic center. Okay. This is stereogenic center. This is stereogenic center. Okay. Stereogenic center means it is a carbon atom because of which geometrical isomerism can exist. Geometrical isomerism can exist. Okay. So here in that EZ isomerism, higher atomic number will have higher priority. These two only you have to compare. Don't worry about these two. Chlorine and bromine. Bromine have higher atomic number, so priority 1, and lesser atomic number priority 2. Out of fluorine and iodine, iodine have higher atomic number, so priority number 1 and priority number 2. So priority 1 are on the same side. Priority 1 are on the same side. Therefore, it is called as a Z form. What it is called as Z form. Now let us take the here. Don't go for the hydrogen. Actually, it is attached with the nitrogen. So you should take the nitrogen atomic number and fluorine. Nitrogen atomic number is 7. Fluorine atomic number is 9. So 9 is more better, so more higher, therefore higher priority for the fluorine. Okay. Same way here carbon and here nitrogen. So nitrogen is 7, carbon is 6. So this will be of the higher priority. Okay. So higher priority on the opposite side. Higher priority on the opposite side. Therefore, it is called E. Okay. So this is only first rule. What does first rule says that group or atom having the higher atomic number will be given preference order 1 and lower atomic number will be given preference order 2. And again I am repeating, you will give these two groups together, these two group together, double bonded carbon atom. Okay. Now let's go for the next. So I think what is stereogenic center, it is clear now. Okay. So the carbon because of which stereoisomers, especially geometrical isomers are possible, then they are called as a stereogenic center. Okay. Now let's take the rule number 2. Okay. So here if you take the atomic number, this is hydrogen, this is deuterium. Okay. So once we take the according to rule number 1, we should take the atomic number same atomic number as a consideration. But problem is that hydrogen also 1H1. Okay. And deuterium also 1D2. So atomic number are same. Then we will go for the if the attached carbon atom or attached atom or group are having same atomic number. Okay. This rule must be used only when atomic number of the group or atoms attached to the stereogenic center are same. Then priority order is assigned on the basis of atomic weight. Okay. So here atomic weight is 1, here atomic weight is 2. Therefore, this is higher priority. Okay. And this is lesser priority. So next here there is no such problem. Here attached group to the carbon atom is nitrogen. and its atomic number is 7. Attached group is carbon, it is 6. Okay, then so higher priority will be to this nitrogen, lower priority will be to this ethyl group. Okay, so look for only group or atom directly attached to the double bond carbon atom. Okay, so higher priority on the opposite side and lower priority on the opposite side. Therefore, it will be E form. Rule number 1 says compare atomic number, higher atomic number, priority 1, lower atomic number, priority 2. If atomic number of the both group attached on the double bond carbon are same, then we will go for the rule 2. Okay. So according to rule 2, we will take the atomic weight. Okay. Now let us see the next slide. Okay, rule 3. In the rule 3, when both atomic number and atomic weight are same, then we will go for the next. Then what we will do? We will do the next group attached here. Okay. Then priority will be decided by the next joining atom. Priority will be decided by the next joining atom. Okay. So here to this carbon atom, this is the carbon. To this carbon, this is the carbon. Okay. So after this, this is also carbon. After this is also carbon. Okay. So then you can keep on comparing. So here this carbon, actually this CH3, no? So CH3, here it is CH2. So the next group attached here it is this third hydrogen. But here it is attached is carbon. Okay. Is it understood? So next here if you compare CH3 and CH2. Okay. So here it will be on the either side. This carbon, this side also carbon, this side also carbon. And here it is only one side only carbon and another side is hydrogen. Okay. So this will be of the lower priority. This will be of the higher priority. This will be of the lower priority. This will be of the higher priority. Again, I am explaining. So to avoid confusion, first, I will compare this carbon and this carbon. Okay. Both atomic number and atomic weight are same. Okay. Then what I will do, I will compare the further atom. So further it is attached to two carbon atoms here. Further it is attached to one carbon. This is further attached to one carbon. Okay. So here it is attached to two carbon atom. Here it is attached to only one carbon atom. Okay. So higher atomic number is for the this carbon atom because it is attached to two carbon atom. Therefore, higher priority will be to this and lower priority to this because this carbon is further attached to only one carbon. This carbon is attached to further two carbon atoms, therefore higher priority. And here only there is no problem of here. This is carbon is attached to hydrogen. This carbon is attached to carbon. So therefore this is of the higher priority. Now higher priority on the opposite side. Higher priority is on the opposite side. Therefore it is called as a E form. Therefore it is called as E form. Okay. Okay, next let us take another example. Here both are of the carbon atoms only. Then we counted number of carbon. If carbon atoms are not there, like here, this carbon is attached to 3 carbon. But here this carbon is attached to oxygen. Then preference will be given to atomic number. When atomic number is same, then only count number of. When atomic number is different, give number atomic number as a preference. Now you don't think about the how many carbon atoms and how many hydrogens. You need not to add them. So here this carbon is attached to 3 further carbon atoms. Okay, this carbon is attached to 8, that is at oxygen atomic number 8. So this is of the priority high. Now you check here. Here this will be done. See, this carbon is directly attached to how many carbon atoms? 2 carbon atoms. Here this is directly attached to only further one carbon atom. This is with some other carbon atom, need not to worry. Okay. So this carbon is attached to one carbon. This carbon is attached to two carbon. Therefore, this is of the higher priority. So higher priority, higher priority. Both are on the same side. Therefore, it is called as a Z form. This is what? Z form. Okay. Okay, next rule number 4. Okay, so what does rule number 1 says? Atomic number. Rule number 2 says if atomic number same, atomic mass you will compare. Rule number 3 says if atomic number and mass number are same, compare the further atoms. If further atom are same, then count number of. If further atoms are not same, count with respect to atomic number. Okay. Now let's see about the rule number 4. If a multiple bonded group attached to the double bond, if a multiple bond, okay, like carbon double bond oxygen, double bonded carbon atom, they are considered in the following manner. Actually, C double bond O for this purpose only. Okay, so it will be considered as carbon attached to oxygen and oxygen attached to carbon. Okay, same way C triple bond A. So carbon attached to three A. Further, A is attached with three carbon because triple bond three places, double bond two places. Okay. So how that can be utilized in the EZ isomerism? Let's check it out. So for example, E form and Z form. Okay. So here this is carbon double bond carbon and it is double bonded to oxygen. It is single bonded to oxygen. Both are same oxygen only. Okay. So but as per the previous rule we say that this carbon is attached to two oxygens. Okay. And this carbon is attached to only one oxygen. So then which will be higher priority? This will be of the higher priority. Okay. And same way here. There is no problem here. Atomic number 7 and 6. So this will be the higher priority. Higher priority on the opposite side. Therefore it will be E form. And let us take the Z form. So here carbon attached to two further oxygen. Here carbon attached to three nitrogens. Okay. Here carbon attached to what? Three nitrogens. Okay. Here carbon attached to two oxygens. So, but atomic number is different. Then we should give preference to atomic number. So this is of higher atomic number. Therefore, priority will be 2. Suppose if nitrogen is there, then 2 nitrogen and 3 nitrogen. That time this will be of higher priority. But here one side nitrogen, one side oxygen. So atomic number is different. So don't worry about the number of, you should worry about the atomic number. Okay. Now let us take here C triple bond. That means this carbon is attached to three carbons. So this carbon is attached to two carbons. So now both are atomic number are same. Therefore we will count the number of carbons. So this is of the higher priority. Higher priority, same side. Therefore, Jesus, that is G cis, Z cis. Cis means same side. Okay. Now let's see the next. Syn and anti-isomer. We have done the two types of, we have done how many types? Two types of geometrical isomerism. Okay. Cis-trans isomerism we have done and EZ isomerism we have done. We are going to do it for the syn and anti-isomer. Don't forget that we are going to study number of isomer which are very important in the integer type of questions. In the integer type of question we are going to get what? We are going to get number of isomers, number of geometrical isomers. So that formula I will be giving in the end of this session. Okay. So syn and anti-isomerism. This type of isomerism exhibited by oximes and azo compound. Okay. What is oxime? That also I will tell you. Actually, you might have studied in the IUPAC naming only. Aldoxime and two ketoxime. There are again further they are divided into two types. Okay. Azo compound. Actually, azo means nitrogen. Okay. So nitrogen containing compounds are called as a azo compound. Diazonium salt. You will, I think, any time you must have came across during the practical organic chemistry. Diazonium. Di means two, azo means nitrogen. Diazonium salt. Therefore, salt means plus or minus must be there. Di means two and azo means nitrogen. So this is the diazonium. Okay. And here it is simply azo compound. That means nitrogen must be there. If they are more than one, then it is well and good. Okay. So oxime and azo compounds can show the syn and anti-isomer. Okay. So what are oximes? Oximes are the compounds formed by reaction of aldehyde or ketone with hydroxylamine. Hydroxylamine means amine means NH2. Hydroxyl means OH. This is called as a hydroxylamine. This hydroxylamine, this is amine and hydroxyl. Okay. So hydroxylamine when treated with whether it is aldehyde or ketone, we cannot say. People think that when I write C double bond, it is ketone. No, don't be in so much hurry. If I write hydrogen now, it will be aldehyde. If I write chlorine, now it will be acid halide. If I write NH2, then now it will be amide. So C double bond O is not ketone. Okay, it can be so many depending on the what groups are attached. Okay. So then H2O will be eliminated. Then it will be resulted in the oxime. Okay. So if suppose I write it here hydrogen, then it will be aldoxime. If I write both side alkyl group, then it will be ketoxime. Okay. So who will show the syn and anti-isomerism? Okay. Oximes of aldehyde always. Okay. Oximes of aldehyde will always show the syn and anti-isomerism. Whereas oximes of only unsymmetrical ketone. If both groups are same, then they will not show the syn and anti-isomerism. Okay. Show the geometrical isomerism. Was it understood? So oximes, how many types? So two types. Aldoxime will always. What is aldoxime? On this double bond carbon atom, if one side hydrogen is there, then it is called aldoxime. So ketoxime, both side alkyl group. If both alkyl groups are different, then they will show the syn and anti-isomerism. They will show the syn and anti-isomerism. Okay. So how they are going to show what they are, that we are going to see now. Now let's take the first example of aldoxime. Okay. See, this is the carbon atom. Now it is attached with the one hydrogen, one alkyl group. This is aldoxime. Okay. Now you will compare the OH and hydrogen. Both are on the same side of the double bonded. Okay. So therefore this is called as the syn. And with respect to double bond plane, okay, hydrogen OH is on the other side, hydrogen is on the other side, opposite side. Therefore it is called as a antiform. First of all, aldoxime, how to identify it is clear now. Double bonded carbon with nitrogen. If it contains at least one hydrogen, okay, then it is called aldoxime. Okay. If both alkyl group, then ketoxime. If both are same, then symmetrical ketoxime. If both are different, then there will be called as unsymmetrical ketoxime. Okay. So aldoxime will always show, and this is how you will identify OH and H on the same syn. OH and H opposite side anti. Okay. When OH group and H are on the same side, then it is called syn, otherwise anti. Now I told you in the ketoxime, it is possible only if unsymmetrical, only if it is unsymmetrical. Okay. So unsymmetrical, like here we have seen methyl group and ethyl group. So this is methyl group and this is ethyl group. Okay. Then what we will do in unsymmetrical ketoxime? If OH and alphabetically alkyl present on the same side. Here ethyl starts with E, methyl starts with M. So alphabetically higher priority and OH on the same side. Therefore, it will be syn. If alphabetically higher priority opposite side with respect to OH group, then it is called as a antiform. Okay. So aldoxam and ketoxam, how to identify EZ isomerism, sorry, syn and anti-isomerism, I think it is clear now. Okay. Now next alpha geometrical isomerism in azo compound. Okay. So here this is what azo compound. Azo I told you nitrogen. Okay. So in this double bond nitrogen, there will be lone pair. Okay. So you can say lone pair on the same side, or you can say groups attached on the same side. Then it is called as a syn. If they are on the opposite side, then they are called as a anti. They are called as what? Antiform. Okay. So this is what syn and anti-isomerism. Syn and anti-isomerism is shown in three type of compound: aldoxime and unsymmetrical ketoxime. Third one is azo compound. Okay. Now let's see the next part. Geometrical isomerism means cycloalkanes. Okay. As of now, we have studied the geometrical isomerism only in multiple bond, double bonded chain only. Okay. And actually, cycloalkane is very simple. See, that plane is only taken as a reference. Up to now, what we have done with respect to double bond plane. But here, what we will do with respect to plane, with respect to this plane. Okay. So with respect to triangular plane, chlorine on the opposite side. So opposite side means it will be trans. Same side it will be cis. Same side it will be cis. Okay. So cyclic compound rotation about CC is not free. Actually, this is attached to this carbon because rigidity caused presence of other carbon. Double bond rigidity already I told you. Now here cyclo also rigidity due to this carbon. Okay. So they tightly held, therefore distributed disubstituted cyclic compound having two substitution separate carbon will show geometrical isomerism. Okay. This is dichloro, that is disubstituted. Okay. Then substituents on the same side are called cis, opposite side are called trans. Okay. Now I told you, I will tell you the how to find out number of geometrical isomerism. Okay. So here I am going to tell you in the different cases. First case 1. Okay. What is the first one? Case 1. So case 1 is about unsymmetrical alkene. Okay. Unsymmetrical alkene. So here this is carbon double bond and carbon double bond. This group is not same as this group. R1 not equal to R2. Okay. Then simply number of geometrical isomerism will be 2 to the power of n. Okay. Where n is equal to number of double bond. Here how many double bonds are there? Two double bonds are there. Okay. And these two groups are not different. So 2 to the power of 2, then we will get 4. Okay. So this is the number of geometrical isomerism. Polyenes. Poly means more than one double bond. Okay. If they are having only one double bond, only simple one cis, one trans. Okay. Need not to count at all. But if they have two double bonds, more than two double bonds, how to count? Okay. Case 1, I think it is clear now. Okay. So let's go for the next one. Case 2, in case of a symmetrical alkene. In case of what? Symmetrical alkene. Okay. And in symmetrical alkene and double bond and number of double bonds are also same. Okay. Number of double bond also will differ. If number of double bonds are even, okay, then P is equal to n by 2. If number of double bonds are odd, then like here 1, 2, 3 3 double bonds are there. Okay, number of double bonds are how many? Odd. Okay, then n plus 1 by 2 that we will use. N is equal to what? Number of double bonds. Number of double bonds is counted as a number of double bonds is equal to 3. Okay, here it is n. And n will counted as even, then we will take a p value. What is this p value? That is n by 2 is p value if even. If it is odd, n plus 1 by 2. Okay, so first condition, first example, this is the example. Here number of double bonds are what? Odd. So I will use this rule. P will be 3 plus 1 by 2. How much it will be? 4 by 2, that is 2. So in this formula, n minus 1, okay, 2 to the power of n minus 1, 2 to the power of 1, and 2 to the power of 2 minus 1, sorry, 2 to the power of 3 minus 1, 2, and 2 to the power of 2 minus 1, it will be 2 to the power of 1. So 4 plus 2, 6. So number of geometrical isomers will be 6. Okay. So if you practice more and more questions based upon this, then automatically this formula you will remember. Okay. So I think these shortcut formulas will be very helpful to you so that you can directly attempt the integer type questions according to the now recent examination pattern. Okay. So this is what today's our lecture. Okay. So we have studied about the specially geometrical isomerism. Geometrical isomerism is further divided into how many types of isomerism? Three types of isomerism. Cis-trans isomerism. Okay. Cis-trans isomerism. Next EZ isomerism. And next is syn and anti-isomerism. Syn and anti-isomerism. Okay. Cis-trans isomerism is, let us take, suppose this is a double bond. Okay. A, B, C, D. Okay. Either A should be equal to B or C should be, sorry, A should be equal to, A should be equal to C. Okay. A should be equal to C, this carbon, or this must be same, or this and this must be same, or A should be with respect to D. But if A should not be equal to B and C should not be equal to D, I am talking about this, not this carbon atom. Okay. If these two groups are same, then there is no cis-trans cis-trans isomerism at all. If these two are same, there is no cis-trans isomerism at all. Okay. If all four groups are different, then we will use which rules? CIP rules. Okay. And syn and anti-isomerism is found in the three condition: aldoxymes, okay, aldoxyme, ketoxyme, but groups must be different, and azo compound, azo compound. Okay, this is the summary of the geometrical isomerism, and last we have studied how to find out number of geometrical isomerism. Okay, I think all are understood clearly now. You will make your own better notes. Okay, these type of things you should practice by writing it. Okay, once you make your own notes, it will be helpful to you for better understanding, not only now, during the revision. Okay, so rank getting will be completely depending on how you revise in the shortest span of time. Okay, so all the best.